In today's lecture, we are going to see another user-defined data type, which is known as union. Okay, now there are certain features which are common between structure and union, the syntax and all, but it has some different kind of implementation. So in case of union, the syntax is similar, but it has certain peculiar or unique features. So to begin with, I will share one presentation. Screen is visible, right?
Yes.
Okay. So the second type of user-defined data type is unions. Am I audible?
Yes.
Yes.
Just a minute. There was some problem. Screen is visible.
Yes.
Yes.
Okay. Okay. So now I was telling that union is a user-defined data type which shares the same memory location. Okay. In structure, suppose we define a structure ABC like this, and we have two variables within the structure, that is a and which is of integer type, and b is a character. Okay, this is the way to define or declare a structure. Now suppose I want to print the address of variable a and I want to print the address of variable b. How can I do it? Any idea? Yes,
Pointer.
you can. Yeah, that's what, you can use pointers. For example, you can say, since I want to access variable a, then pointer type should be integer type, asterisk p is equal to ampersand a, and then you can print the, you have to print what? P. You have to print p so that you get the address of a. Or there is another way. You have to simply, do you know the other way? Simply you have to use ampersand a, which will print the address of a. Right? Ampersand operator is to obtain the address of a particular variable. Similarly, you can do it for variable b. And I come to know that variable a, it occupies how many bytes? Anyone can tell?
Four. 4.
4 bytes.
Yes, very good. It occupies 4 bytes. And character b will occupy 1 byte. That is why, yes, that is why address of a is say 24, and after plus 4, that is, it is occupying 4 bytes, so plus 4, and then at 28 you are storing the character b. Okay, so this is how we know that integer occupies 4 bytes. Now if I define a union, okay, this is the syntax to define a union. Union ABC. Suppose the name of union is ABC, the keyword to be used is union. Just like how you use struct for structure, like that union for union, it also can have variables within it. And at the end, you need a semicolon. Okay, syntax is same, only one keyword is different, that is union keyword. Now, as I said, unions will share the same memory location. Means when you go to print the address of A and B, you will get the same address. If you get the same address for A and B, it means that A and B are stored at the same memory location in the same block. Okay, A and B are stored in the same memory location. Now, what is the difference is, if you consider structure has two variables A and B, then in memory, first A will be stored 4 bytes and then next you'll store B. Okay, two separate memory locations. These are a group of 4 locations for A and one location for B. Means one after the other you can store the structure variables. But in union, you have just one memory block, and in that only you are storing A, and in that only you are storing B also. Okay, so what effect this will have, we will discuss now. See here, another diagram. A variable occupies 4 memory locations because 4 bytes. So 4 blocks, each block is of 1 byte or 8 bits. You have stored A in 4 memory locations. Okay, means A will occupy in total 4 locations, and character B 1 location because byte. Okay, this is one by one you are storing them in memory, one after the other. But in union, you have a character which occupies 1 byte. So the first block says for character, and then including that block, next 3 blocks you have to consider. Means total 4 blocks for integer, right? Because integer occupies 4 bytes. This is the meaning that they will occupy the same memory location. Okay, this is the meaning that they will occupy the same memory location. Suppose you have a short variable, short C, short type, short, that occupies 2 bytes. So it will start from this location and till here. These 2 blocks will be occupied by short C. That means the starting location is same for all the variables of union, right? It depends on the size of int, char, short, float, but the starting will always be the same location. Have you got this difference?
Yes.
Yes.
Okay.
Yes.
Now, in union, members share the same location. Suppose we make change in any one variable, then since all are stored in the same location, whatever change we make will be for all the variables of that particular union. As we saw, B and A are stored starting from the same location. So if I make some change to A variable, suppose I change the value of A, then it will affect the value of B also. Okay, such applications are handled by union. Similarly, if I change the value of B, it will affect the value of A also. Okay, any one variable you change, it will affect everyone. For example, we have the same union ABC. You can create a global variable of the union like this. After the closing bracket, if you write the variable name, it is a global variable of the union if the union is in the outside all the functions. If union is within some function, then this var is a local union variable. Okay, so var is a type of variable whose data type is union ABC. Now, how can we access the values of this union? Same like structure. We must write the structure variable name, suppose var dot the variable name, suppose A. Similarly, we can write var dot B to access the character. Okay, we use the dot operator for that. We know that. And we can print the value of, we can either assign it 65 value, means we can store or initialize the values of the variables of the union, and we can also print it by this syntax. We have seen this. So what will be the change now? Now in this program, we have seen that we have initialized a variable to 65. Now I said that if you do some change to some variable, it will affect the remaining variables. Now B is a character data type. So if A is 65, then B is a character, means B will actually correspond to the ASCII value. Means ASCII value of is 65 and the variable corresponding to that is capital A. Means what you have done, in the variable int A, you have stored 65. And since B is also a union variable, this will affect the value of B. So even if you don't initialize B to any character, it will take the value corresponding to this ASCII value. So if ASCII value is 65, the character will be capital A, and capital A will become the value of character B. Okay, I repeat whatever I said. If you change the value of any one union variable, it will affect the other values also. For example, if I make A is equal to 65, it will affect the value of B. Means if you don't initialize B, B will be equal to the character corresponding to the ASCII value 65, right? So B will become capital A. Have you understood this?
Yes.
And if we suppose put a equal to some value which is not an ASCII value, then what
Yes.
will B will store like?
B, see, I'll just show you 1 minute the chart of ASCII values. So this is the all the possible ASCII values. So as you can see, it is starting from 32 for space character, and then it goes up to 127. So if we give some other value to A, okay, if it is within this range, it will be the character corresponding to this ASCII value. But suppose we give to if we give a value which is not within the ASCII range, then we will actually execute a program now after a few minutes, and I will show you. So if you have the value from 32 to 127, it will be correspondingly ASCII value corresponding to that the character will be. So suppose I run a program for that. That time we will see what will be the value. Okay, we are going to see the programs also based on unions. So for now, you
Okay.
can remember this particular example. Yeah. Okay. So 32 to 127, that is ASCII range for the C programming. Now, how
So
is the size?
as you said in just in that four thing, a variable char would be stored, right? B. So in one CPU cycle, both of them would be read, no? Both int A and char B.
Yes, yes, both will be read.
Okay.
Yeah. Whatever is present within that four memory locations, let it be anything, any value, it will be read. Now, if we make changes on one variable, it will be reflected in the other. So how can we determine the size? Now, size means how if we were dealing with structures, then we know that either there is padding or there is packing. By default, there is padding. Okay, so we can easily, if there is packing, we can add these sizes. Int occupies 4, char occupies 1. If there is packing, directly we can add it. 4 plus 1, 5. Even if there is padding, we know how to do it. But in union, there is no padding and packing. Okay, so here the concept is that the total size of the union ABC will be equal to the size of the largest data type. Here int occupies 4 bytes, char occupies 1 byte. So the largest size is 4 bytes, and that will be the size of union. Okay, because we know that they are starting at the same locations. They are getting stored from the same location. So the size is obviously equal to the largest size, right? If we have a double variable, it occupies 8 bytes, and the others are int, float, and all. Definitely double will occupy 8 bytes, and nothing will occupy greater than 8 bytes. Suppose you have float, it will occupy 4 bytes. You have integer, it will occupy 4. Character occupies 1. But maximum is 8 because you have a double variable. If you have beyond double, then that will become the largest size. So whatever is the largest size will be the size of the union. For example, as I was saying, you have integer, you have character, you have double, and you have float also. So if we study this memory block, let us see how it will happen. Character will occupy 1 byte. Int will occupy these 4 starting from the same location. Float will also occupy these 4 starting from the same location. And double will occupy these 4 plus next 4. So this whole block will become the size of this union, that is 8 bytes. Suppose you had long double, then that would become the size of the union. Have you understood this? What is the size of a union?
Yes.
Yes.
Okay. And you can print the size using the size of operator. We know this. So syntax is more or less same, only the keyword is different. So size of int, char, double, and float I have written over here for my machine. Maximum is double, 8 bytes, so that is the size of union. There is no padding or packing over here because starting location of storage is same. So output is 8 because it is double is the maximum. Now we can access the members of union using arrow also. We know that we can access using this dot operator. Suppose the structure name or the union name is var, then var dot a or var dot b. We can write like that. This is using dot operator. Similarly, we can do using arrow operator. For that, you need to declare a pointer to a union. For example, if you have a variable var, which is a union type of variable, you have stored the or initialized the a variable or a part of the union by writing var.a is equal to 90. Then you can create a pointer to this var variable. That means you're creating a pointer to union type of variable. That means data type of the pointer also will be union, and not only union but union and union name, that is ABC. That means the type of the pointer is union ABC. Suppose the pointer name is ptr, you must write here asterisk ptr is equal to ampersand var, right? Like this you can create a pointer to the union variable, and then you can write ptr arrow a, and you can print this value of ptr arrow a. You will get the value 90, whatever you had initialized. Now b is the character. If a is 90, then b will be the character corresponding to the ASCII value 90, and 90 is that of capital Z. Okay, I have not attached the output screenshot, but 90 is the ASCII of capital Z. So the value of B will be nothing but Z. If you print it, the value of B will be Z because A is 90, correspondingly ASCII value, you'll get capital Z. Have you understood till now how you can use unions?
Yes.
Yes.
Okay. Now see the application part of unions. We have seen that the same memory location will be used. But what is the use of this? If we change value of one variable, then value of some other variable will get changed. So it is not always used. Only in specific applications you must use the union. For example, suppose I'm considering a real-time example. You have a store or a shop which sells two kind of items. Okay, the shop is selling books and as well as shirts or clothes. Now books will have its own characteristics. Suppose the type of the book, the author of the book, number of pages of the book, size of the book, then the book cover or the color of the book. Many attributes or parameters you can have. Similarly, if you are buying a shirt, then the size, color, the pattern, if there is a pocket or not. Okay, we know all those things about the characteristics. So to keep a record of all these parameters, either you use structure or you use union. Now in such a case, a better option is union. I'll tell you why. Now suppose the book has the parameters or the characteristics like title, author, number of pages, price. Now shirts can have color, size, design. Shirt can also have price, right? So here we know that the parameter price is same for both books and for shirts, right? And because of this, we will use unions. If there is a common parameter like this between two or more entities or two or more variables, then we can use union easily. Now, suppose we had not used union, we had used structure, then what we had to do? We had to create a part of price, another field would be title, another would be author, okay, then there would be number of pages, color, size, design. Now, seeing this, we can say that price is for both book and shirt, title can be for book, author is for the book, number of pages for the book. Now, what about the shirt? Shirt will have, suppose here in this case, shirt has color, size, and design. So some variables are for the shirt, some are for the books. But there is one common variable, price. Okay, let me write here. This is for the book and this is for the shirt. okay, in this program, and price is for both. So here if I'm using structure and I want to access only the details of book, then why should I use or allocate memory for the variables of the shirt, right? I'll be simply wasting the space. I want to access only book ka details. Then I should not access the details of the shirt. That means I don't have to allocate memory to the variables of the shirt. So either you create two structures or you create one structure and waste memory. Okay, what are the alternatives? You use two structures, one structure for book, one for the shirt, or you use one structure but then memory wastage is there. So structure is not a so good idea, okay, if you want to optimize your program. So we can use union, right? As I was saying, if you want to access only for the book, then you create a structure variable name book, then book dot title you can initialize, book dot author you can initialize, book dot number of pages, book dot price, and remaining it is not related to the book, so I will not initialize, I will waste memory. To solve such problems, you have to use, and also as I said, wasting memory means what? Size of the structure will increase. Here there is 44 bytes, okay, considering you can add these later on and then 44 bytes you'll get it. So now suppose the price is double, so it is 8 bytes. Suppose this string character, suppose I initialize it with the size of 8, okay, suppose my title maximum can be of 8 characters, then the string will be 8 byte string. Then author also 8 bytes. Suppose number of pages is integers of 4 bytes. Color also, if I want to specify an integer value of the color, then I can have 4 bytes. Size again integer 4 bytes, and string suppose 8 bytes I have initialized the size. So if you add all of this, you will get 44 as the size of the structure. To reduce this size, I will use union. Now I will not use union only union. I will use structure, and inside that I will use union. See, for example, I have a external or outermost is struct store. Within the store, I have the price variable because it is common to both. Okay, price is like a global you can consider. Okay, sort of global, not actually global. It is global means it can be for the book also and for the shirt also. So that is first variable I have mentioned within my structure. Now my second variable is a union, as you can see. Okay, this whole thing is my second variable. My second variable is nothing but a union. My third variable, just a minute. Okay, my first variable is the price, which is common to both. My second variable is a union. My third variable is another structure. Okay, this is my second variable, this is my third variable. And I have created the variable of the store, that is the outermost structure. For that, I have created the variable item. Okay, and using this item, I can access the values of this store. Whatever is inside the store, I can access using item variable. So how this will work as, I will create one variable of the store. Okay, just a minute. I have made one small error. Union is not only the second variable. It is this. This is my first variable. Then there is a union, and within that union, I have a structure. Okay. Within that union, I have a structure, and within that same union, I have another structure. And for this union, I have created item variable, and then for the external store, I have not. Let me show you on Notepad. It will become easier for you. See, I have a store. Within that, I have the price variable. And within that, I have a union. Then within the union, I have another struct. Within that same union, I have another struct. And then that is it. Okay. That means within store, I have a price variable and a union. Within that union, I have two structures. Is it clear how I have defined it?
Yes.
Yes.
Okay. Okay, till now you have understood. Now for this external store, outermost store, I have not created a variable as of now. then price is there. Then in the union, I have created the variable item, right? As you can see here, item is for the union. And the first structure within the union, I have created book variable. And for the second structure within the variable, I have created the shirt variable. That means in the store, each item has a price. Then one item is a book and another item is a shirt. And that both those items I have written within the union. So now, see, I've created a variable s of the store, s dot item. That means s means I'm referring to the store, and within that store, item is of what? It is of the union. That means first s, outermost, then I'm coming a little inside. I've created item, which is of the union. Then in the union, I have two structures, so I can access another thing. Book is a variable of the first structure. That means I can write s.item.book, and inside that book structure, what do I have? I have title, author, and number of pages. So book dot title I can access, or book dot author I can access, or book dot pages I can access. Have you understood? That means I cannot access the variables directly. From the outermost to the innermost, I need to keep placing the dot. Outermost is a structure and it has the variable s. So s dot, then come little inside, you have a union. Union variable is what? Item. Then within the item, you have a structure variable book. So put a dot book, and within the book, you have title, author, number of pages. Have you understood how I've accessed these items?
Yes.
Okay.
Yeah.
Similarly, I've done it for title. Now you can do it for author. Same thing. Only instead of title, you have to write author, and number of pages you can do. Means what I've done here, I have not initialized the shirt ka variables. I've only used, or I've dealt with the variables related to the book. How I can say that? Because I have only the variable book over here. If I want to access shirt, then I have to write s outermost. Then I have to access the union. What is the variable of the union? Item. Then within item, I have what? Shirt. Dot shirt. And that shirt, again, it has certain fields. What is it? Color, size, or design. Suppose size. Okay, this is how you can access the variables. Suppose I want to print the size of the union. Then which variable I'll have to access? Can you tell me? I want to print the size of the union. Which is the union variable here?
Item.
Very good. It is item. Union variable is item. Okay. So if I want to print the size of the union, first I must write s dot item, and I have to take the size of this, size of s dot item. Okay. Let this, I can print the size of union. But what will be the size of union? The size of the largest variable of the union. But now instead of variables, I have structure. This whole structure is a variable of the union. This whole structure is a variable of the same union. So the maximum size between these two structures will be the size of the union. Do you agree with me?
Yes.
Yes.
Yes. So let us now suppose assume that you are using packing. Okay, that means we are not leaving any empty spaces in between. There is no padding. We are using packing. Okay, it will become easy to study this then. That means suppose title, this string has 8 bytes. Then author is another string, 8 bytes. Means I have initialized this size for it. Number of pages integers are 4 bytes. 8 plus 8, 16, 16 plus 4, 20. Now let us see the second structure. Color is integer. Then you have size, again it is integer, and design character, suppose 8 bytes. So 4 plus 4, 8, 8 plus 8, 16. This is 16. So as you can see, the first structure size is 20, second structure size is 16. The maximum between this, or the largest, is 20. So the size of this union will be 20 bytes. Okay, this is how you can know that what is the size of the union, 20 bytes. Now we know that what is the size of the union. Okay, so this is my union. I'll just mark it as a single thing, union. Okay, union is one variable. And there is another thing, that is price. So price and union are the variables of this outermost structure, right? Store structure has two variables. That is the price, and another variable in the store is the union. So the structure, the store is a structure. So you have to add the sizes. Price ka size is double, that is 8, and union is what? 20. So the size of the external outermost structure is 20 plus 8, 28. Okay, we have found out the size of each thing now, and you can print it however you want. So have you understood now? That means if we want to access the fields of the shirt, then what will be the maximum size of the, what will happen? The structure book will not get allocated any memory, and the memory will be only allocated for the shirt. Okay, using dot operator, we can initialize the fields of the book structure, and memory will be allocated only for this shirt or only of the book, not for both. Okay, and union is nothing but size of the largest. So we are actually saving space. If union, instead of union, I had used structure, and within that we had these two structures, then the size of the structure would be what? 20 plus 16 would be the size of the structure. But instead of structure, I've used union. So 20 or 16. Maximum is 20, so that would be the size. So from 44, that is 20 plus 16, we have directly gone to 20, right? We have reduced the size. So this is the use of union. Have you understood why we have used union? To reduce the size. Is it okay?
Yes.
Yes.
Okay. So this is how I have reduced the size. So this is nothing but the nesting of the user defined data types. Okay. So this is how, this is one application. Okay. This is the most complex application. Other applications are simpler, which I'll show you. So as I was saying, this is 20, this is 16. 20 plus 16 is what? It will, maximum between them is 20. Okay, so that will be the size of this union, 20. And this price variable is 8 bytes. So size of the outermost structure is 20 plus 8, because it is a structure, you have to add the sizes 28. Okay. And we know that 44 is less than 28. Size of the outermost structure was 44. That has reduced to 28 because of the use of union. Now, I'll execute some program and show you. See, now A was a variable, B is again a variable within the union ABC. Then I have initialized A as 65, and I'm printing the value of A and B using dot operator. So let us see what will happen. As I said, A will get initialized to 65, and B, since it is stored at the same location, corresponding ASCII value, the character is A, and that will get stored in B. Okay, now if I change A, let us see if B changes. If I make A as 67, then it should be capital C, right? It is changing. That means if one variable is altered or changed, the other variable will also get changed. Now, if we put a non-ASCII range, let us see. We saw that 32 to 127. So if I put the ASCII value, if I store the value 12, then let us see what happens. You're getting garbage value, right? This is some character or a garbage value. Suppose I change the ASCII range. Suppose I change the value of A. I put it as 300. See, you're getting a comma. So you'll get any value, any garbage value or any value which is present at that memory location by default. Have you understood what happens by union?
Yes.
Yes.
Okay.
And
Yes.
in the code you have written int a, no? So if we write for some decimal value, and if we write decimal of 67.5, then what will happen?
Okay, let us run it. So since A is an integer, it is taking the integer part, that is 67, and corresponding ASCII is existing. Now suppose A is float, and I'm running this program. So we know that the if A is float and you're storing in a 67.5, I need to change my format specifier, right? Instead of %d, I should use %f. And now I'll run it. So B is not getting any value, right? If I change the value, if I write 70.5, B is not getting assigned anything. Now suppose I do some type casting. I keep this as int. Okay, I'm assigning a floating point value to an, I'm assigning, let me keep this float, and I'm assigning an integer value to the float, right? So still it is not getting assigned because A is primarily a float, it is not an int. So ASCII values are integers only, right? From 32 to 127 is an integer. That means if you have something which is not an ASCII, you will not have a corresponding character, right? Have you understood?
Yes.
Okay. Now another application. Now I will show you some application, but before that, can you give me some application where I can use this union? Just anything you can guess and tell me where I may be using this union or how I can use it. Okay, I'll give you an example. Suppose you want to calculate the area of a square. Now we know that square, all the sides have the same length, right? So suppose the four sides of a square are A, B, C, and D. Now each side has the same length, okay, because it is a square. So variable A, suppose it is 20 centimeter. That means side of the square is 20 centimeter. Okay, let me draw a square and show you so that it becomes clear. Suppose A is the variable and have initialized A to 20. Similarly, this is the side, this side. Then we have another side, and that is handled by B. And B will also be 20, right? Because it is square. Similarly, this side is C, suppose it will also be 20. And suppose the last side is D, that will also be 20. So why to initialize 20, 20, 20, 20 again and again? So here I can initialize only A by saying 20, and then I can print the length or the area of the square. Okay, area is nothing but side square, or if you want, perimeter is nothing but sum of the sides of the square. So I can write perimeter of square is %d, and then I can simply write var dot a plus var dot b. I've only initialized a, but that will become for all the variables of the structure. Var dot b plus var dot c. Okay, so perimeter is nothing but the sum of the lengths of all the sides of the square. That is what I've done here. So let us see if we get 80. 20 plus 20 plus 20 plus 20, that is 80. See, you're getting 80. Means what is happening? You have efficiently reduced the effort to design the program, right? You have only initialized one variable, and that is becoming for all the variables. So this is a good application of union. Do you agree with me?
Yes.
Yes.
Yeah. You can also have a single variable and write 4 into var.a. You can also write 4 into var.a. It will give you 80. But I just wanted to show you the application of union, and this was, I think, the best application. So I use this way. You can also write 4 into variable or simply add each thing. Now another thing that I want to show you about union is I have initialized a is equal to 20. Then I have initialized b is equal to 16. Then I have initialized c is equal to 30 and d is equal to 23. Now if I have initialized a, I have not initialized other three variables. Then b, c and d all will be equal to 20. Now suppose I have initialized b and a, but the program is read top to bottom. So first a is there. So at this point, when it reads line number 13, then a is equal to b is equal to c is equal to d is equal to all are equal to 20. That is value of a. But when I come and run or execute or compile the line number 14, then a, b, c and d all will be equal to 16. When I compile line number 15, all the variables will become equal to c variable, that is 30. If I write line number 16, then all the variables will become equal to the value of d, that is 23. That means whatever is the final initialization, that will be the initialization of all the above variables also. Do you agree with me? Because they share the same memory location. Is it correct?
Yes.
Yes. So let us also run this and see. So if I'm printing the value of a now, it should be 23, the most recent value, right? It is 23, as you can see at the output. So this is another application where only the final or the most recent initialization will be considered. Suppose in your program, you are entering the value of ABC, and then suddenly, due to some reason in your program, you want to make all the variables equal to 20. Then just initialize or change the value of any one variable, all will change, right? So such applications you can develop using unions easily. So this was it for the unions part. It is a small topic, not like structures. Have you understood unions?
Yes.
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 Okay. Now another interesting data type is enumeration. ENUM, that is the data type enum. Okay, I'm saying enumeration, but the data type is enum. Like how I say integer, but the data type is not integer, data type is int. Similarly, it is enumeration, but the data type is enum. ENUM. Enumeration is again another user-defined data type, and it is used to assign, or it is used to create the named integer constants. I repeat, it is used to create named integer constants. Means what? You have an integer or an integral. Integral constant is nothing but an constant which is the value of an integer. For example, if I write hash define a space 20, then the value of a will be 20 throughout your program, because a is a constant over here. Okay, a is a constant whose value is 20. That means actually I want to write the value 20 as a constant, but I have to store it in a variable, and that variable will have the constant value 20. So a is the name for this constant, right? I want to use the constant value 20 for all the arrays. Suppose array size, I can define array size maybe 10, 20, 30, 40, anything. Suppose I have 5 arrays and the size of each array I want to keep it as 20. Then instead of writing a within square bracket 20, b within square bracket 20, I can define this constant, and then I can use that as the size for all the arrays. That is why we use constants in a program. Constant means whose value cannot change further in your program. Now we can give certain names to these constants. Okay, like how I've given the value 20 the name A. I can give similarly the value 30. I can give it the name as B. If I want to create a value 30 as a constant, I will name it B, suppose. And wherever I write B, it means 30. So this is known as naming the integer constants. And it is easier with enumeration due to some reasons that we will study. So it is also similar to your structure and union with certain differences. Okay, I'll show you one program directly. Similar syntax of declaring enum keyword, the name of the enum week. Then you have certain variables like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. These are the variables of the enum. We have done similar thing for structure, right? We had variables within the structure, we had variables within union. These are the variables within enum, but these are not the variables. These are the names of the constants. Okay, this is the difference. Another difference is you must not write semicolon at the end. You have to write a comma. Okay, Sunday, comma, next variable Monday, comma, next variable Tuesday, and so on. And for the last variable, after that, comma should not be there. That means this is a list. I have written this vertically to show you the similarity between structure and union. Suppose you write the same thing horizontally, then you can write the same thing horizontally like this. I'll just show you. You can write enum, name of the enum is week, within your curly bracket. Here I can write Sunday, comma, Monday, comma, Tuesday, comma, Wednesday, and so on. And I will not give a comma after Wednesday. Means this is nothing but a list, right? This is a list. Same thing you've done for arrays while defining the arrays. You've given commas between the elements of the array, right? So it is the same thing. So this is the horizontal way, but to show a similarity between the syntax of structure, union, enum, I've written it vertically, right? Have you understood how we can define the enumeration type? Have you understood?
Yes.
Yes.
Yes. Okay. And now let's get back to theory. Now suppose you have an enum bool, bool standing for boolean, and you have the elements false and true. Now enumeration, what it will do, with corresponding to the value false, false is a constant, it will assign automatically, it will assign the value 0 to false. Next, you have the element true, automatically it will assign the value 1 to this true. If you had another variable c within your enum, it would be the value 2. So what is the use of this? You can create a variable of enum type, enum bool, name of the enum enumeration, where I've created a variable and I'm writing var equal to true. Now true is standing for what? It stands for the value 1. So var will become equal to 1. And then I can print the value of var. Output will be 1. Right? So here what is happening? The elements of the enum are getting assigned the integer constants. And these integer constants have the names like false and true. So I can assign that constant value to a variable whose type is enum. Right? Only to the enum type of variable, I can assign this true and false. And true means nothing but 1 over here, and false is nothing but 0. And I can print the value of var. So false and true are the names of the integer constants. And if we do not assign the values to these names, automatically compiler will assign the values starting from 0, 0, 1, 2, and so on. In this example of Sunday, Monday, Tuesday, Sunday corresponds to the integer value 0. Means if I want to mention 0 anywhere, I can simply write sun. If I want to refer to the value 1, I can simply write mon. Okay. Similarly, Wednesday will be equal to 3, Thursday will be equal to 4, Friday will be equal to 5, and Saturday equal to 6. But what is the use of this? As I showed you, using hash define preprocessor directive or macro, we can define the constants. Then why do we need enum? One reason is the hash define that you use, it will exist for throughout your program. Wherever you write that variable, it will be accessed throughout your program. But enum can be local as well as global. We have seen local structure, global structure. If enum is within a function, only within that function you can access that enum. Enum will be local there. But suppose you define enum outside all the functions, it will become global. But that is not the case with hash define. Hash define means throughout your program that will be used. Have you understood the difference? Why we need enum?
Yes.
Yes.
Yes. Another use is automatically they get initialized. If I write hash define, I must write hash define a and 20. Then another constant, if I wanted, hash define b 30, hash define c 15. But here what is happening? You can get the values automatically. Compiler will do it for you. Right? Is there any doubt? Okay. Now, examples of these two reasons. First reason is because they can be declared either in local or global scope. Example, here I have declared it within the main function. So I cannot access this var variable outside any other function. This enum cannot be accessed outside the main function. Another thing, automatically initializing will happen. False is nothing but 0, true is nothing but 1. Suppose I had another variable, it would be 2, another thing would be 3, and so on up to infinity. Okay, there's no restriction. Means any value. And var you can assign, because var is an enum type, you can assign anything within this elements. Suppose I have false, true, a, b, c, d, anything can be the value of var. Now some important facts, and I think now your doubts will get clear after reading these facts. 2 or more names can have the same value. Now what was happening? If I had this enum point, and within that I have x, comma, y, comma, z, then automatically it was getting initialized to 0, 1, 2, and so on. But I myself can also do the initialization. I can write in the same place, I can write x is equal to 0. I can have the same value y is equal to 0. Then I can have the same value z is also equal to 0. I can have another variable, suppose a. I can initialize it to any other value, suppose 2, comma, any other value, suppose y, suppose k, equal to any other value 15. Okay, you can create a collection of such constants using this enum. And not necessarily using the var variable you have to access. Means here what we were doing, we had a var, then that var was equal to something which was defined within the enum. True, false is present within the enum, that I can assign to my var, and I can print the var. But I can print the value of this xyz elements directly also. Right? Have you understood the difference? With var, that means before you have to create a variable of the enum, or without creating a variable of the enum also you can print the values of the elements. Is it clear?
Yes.
Like
Okay.
in initialized x, y, and z. After that, if I write p uninitialized, then what will be the value of p? 0 or 4? Because it is at the fourth position.
See, that is another fact which we are going to see just now. Okay, there I'll answer your doubt. So here for this fact or this point or this rule, I have initialized all to 0 and they can be printed without any error. Okay, 0, 0, 0 will be the output. Now, as you were asking me your doubt, the second fact or second rule, I'll first read it out. We can assign values in any order that we have seen. I can write 15 here for y. Suddenly I can write 25 for z, no problem. But if anything is uninitialized or unassigned, or I have not stored any value, then the value of that particular variable will be the value of the previous one plus 1. For example, here I have y is equal to 2, then I have x is equal to 34, then t is not initialized, z is equal to 0. So the value of t will be nothing but the previous value, that is 34, plus 1, that is 35. When I run such a program, I will get y as 2. Okay, I have first printed x is 34, then I printed y, that is 2, then I printed z, that is 0, and then t will be equal to 35. That means one more thing, I can print these values in any order, not necessary first I have to print y because I've written it first. Since I've written x second, I have to print it second, not like that. You can print in any order. And the values that will get initialized depends on the previous value. Okay, have you understood? Is your doubt clear?
Yes.
Now, if I have another way I want to show you, suppose I have y is equal to, suppose I have y is equal to 2. Then I have z, then I have x, then I have W equal to 10, and then I have A. So here y is equal to 2, z will be 2 plus 1, that is 3, z is equal to 3 now. Then x will be what? 3 plus 1, that is 4. So this way consecutively they'll get assigned. Then in between I have w is equal to 10. Okay, the sequence will be broken now. W is 10. What will be the value of a? 10 plus 1. Previous value plus 1, a will become 11. So this way, either let the compiler do it automatically, or in between you can change the value. You can assign your own value, and from that value onwards, you will start now by the compiler. Is it okay? Have you understood?
Yes.
Okay, and only integer constants are allowed. If I write y equal to 2.5, it is not valid. It will give you an error. It will say that enumerator value for y is not an integer constant. That means only integers can be the values over here. Compiler also uses integers, right? 0, 1, 2, 3, 4, and so on. You should also use integers. Now, if you have two enums, 0.1 and 0.2 enum, you have x, y, z in both the enums. You have x in both the enums. In first enum, what are the elements? You have x, you have y, and you have z. In the second enum, you have the elements x, p, and q. Now I said that without creating a variable of the enum, you can print it, right? Either you do enum 0.1 and then you create a variable var. Then you can write var is equal to, suppose, x. Okay, this is possible. Or you can simply access these x, y, z directly. You can print them, right? We have seen that as one of the facts. But now x is for 0.1 enum also and 0.2 enum also. So what will be the value of x that is printed? It will give you an error. It will say that redeclaration of x is present in your program, so it is giving an error. So if you are printing the values of the x, y, z, and if they are duplicate in the enums, it will give you error. But if you create a variable of the enums, it will not give you an error. For example, if I write over here, I write var semicolon. So var1 semicolon is a variable of 0.1 enum. Then I have var2 semicolon is a type of 0.2 enum. And then var1 equal to x is okay. var2 equal to x is okay. But directly it will give you an error. Right? So these are some facts and some applications of enum. Now quickly we'll say one program. You have an enum over here, Sunday, Monday, Tuesday to Saturday. And then I have a variable day 1 of the week enum. This enum name is what? Week. I have created a variable of that enum day 1 and day 2 also. Day 1 equal to TUE. Now TUE stands for which constant? 2. So when I print the value of day 1, I'll get the value 2. And here 5 is the integer value. So corresponding is what? Friday. And I will get the value 5. Right? When I print day 1 and day 2, I won't get Tuesday and 5. I'll get the integer value of Tuesday, and 5 is already an integer. So that will get printed as 5 only. So when I run this program, you can see Tuesday has become 2 and 5 is remaining 5 only because integer value will get printed. We cannot print tu, mon, sun, sat. We cannot print that. We can print only the integer value because we are creating the named constants. We cannot print the constant name. We can print the value of that constant. Now I have another variable day of the week enum, and I'm telling enter a number between or from 1 to 7. And I can store that number, whatever the user enters, in the day variable. Okay, and day ka possible values are what? The possible values of day are between or from 1 to 7. So day may be 1, maybe 2, maybe 3, or so on. So I've used switch case for the possible values of day. But here instead of case, I will not write 1, 2, 3, 4, and so on. I can write sun, month, tu, and all that because they are the named constants. Sun represents nothing but 0. Sun represents 0, mon represents 2, sat represents 6, and so on. So what I can do, I will tell the user to enter an integer. I will store it in an enum type of variable. And that enum variable I can use in switch case because it is a constant value only. It is an integer value. And the possible cases are sun, month, Tuesday, and all. And for whichever case, I'll print Sunday. If it is case two, I'll print Tuesday. Case wed, I'll print Wednesday, and so on. Okay, have you understood this application?
Yes.
Yeah. Now there is something missing in this switch case syntax, which will cause undesirable output. It will not give error, but it will give undesirable output. Can you guess what is missing in the switch case syntax?
The last part of the switch case. Uh,
What is the last part?
else part.
Default case.
Default case.
Yes, default case. But
Default.
that is not compulsory, as I said, right? Okay, that means if user enters 23, suppose that is not from 1 to 7. Okay, that is one thing. It will give, that is for the invalid test case. But there is another thing which will give you a serious problem, which is that
Break.
yes, break is correct. Okay, very good. Break is correct. If I don't give break, what happens? All the cases will get executed from whichever is matching. Let me run and show you. Suppose I enter the number 4. Okay, and 4 corresponds to which? Thursday. So the case for THU that will should get executed. But I don't give break, then Thursday onwards, whichever case are there, they will get executed. So I'll get Thursday, Friday, Saturday, as you can see. So that is why I must give break. Have we seen this in some other program also when I was explaining switch case? Do you remember which was that program? Where I told you don't give break, then it will ease your programming. Do you remember which was that program? We had to write the whether the input is a constant or a vowel, right? In that program, we have used that. I hope you can recollect. So now I've given the break. Now if I write 4, only the case for Thursday gets executed, right? So this is another application of enum, where instead of writing 1, 2, 3, now see here, what is the application or benefit? I don't have to remember that 0 represents Sunday. Means if I write sun over here, means I know that I have to print Sunday. If I write mon over here, I know I have to print Monday. If I write sat over here, I know I have to print Saturday. Suppose the case was 6, that is an integer, then I have to always look up here. That 6 means what? Is it Friday or Saturday or Thursday? Then I have to decide and print Saturday. But here, since it is a named constant, it is indicating that sat means I want to print Saturday. So have you understood enumeration?
Yes.
Yes.
Yes. So if any doubts, you can ask me and put your attendance in the chat box. We have finished all the user-defined data types, structure, enumeration, and union.
Like if we cannot use enum for float type, like for decimal value. So if I want a variable like pi equal to 3.14, and I want to use it for both globally and locally. So how can I use it then?
No, you can't use it. In enum, only integer constants can be. So if you want to use pi, you have to either use hash define, or you can use this one. You have to write const, const, const keyword. Then suppose a is the variable equal to 3.14. Const float a, float a equal to 3.14 semicolon. So a is a float variable and it has the constant value which cannot change, 3.14. Const keyword, or either you can use hash define a 3.14. In this case, you have to not write data type. In hash define, you can directly write the value. But in const keyword, you must write data type and then the constant value. If you go to change the value of a, it will give you an error, right?
Like if we write the same variable const a, and then in enum we again use the variable a. So can we change to that?
Okay, let me check. If I don't use hash define, I'm using constant a, and then a is over here also. Let me make this case a. If I enter 0, it's giving you an error. Okay, that means a value cannot change. It is redeclared. Okay, first of all, it is redeclared. A is here also and here also. And another thing is you cannot change the value of a. Okay.
Okay, so if we write const float that statement after enum statement,
Then also same thing, because A is being redeclared in your program, right? I'll show you that also. So it's giving error for that case, or wherever it is redeclared, it will give an error, right?
okay, got it.
Yeah. Any other doubts? If you put your attendance, you can leave this meeting. Thank you. So next time we will see the data structures part, that is stack and queue.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you.
Welcome.